So this is our 1.6, and in 1.6 we had the absolute value inequality and absolute value equation. Okay, so let me just make a revision of what we did. Okay, so we have an absolute value equation. So let's say our absolute value equation is absolute value of x is equals to a. Okay, and when we are solving the absolute value equation, we have to get rid of the absolute value, and when you get rid of absolute value, we get the two equations. So your first equation is, you write down whatever you have inside the absolute value equals to positive of right side. Okay, or you're going to have whatever you have inside the absolute value equals to negative of whatever you have on the right side. Okay, so you get the two equation, you solve these two equation, and you get the solution for the absolute value equation. Okay, and the next thing, if we have the inequality, so let's consider we have absolute value inequality, absolute value of x less than equals to a. So if we have absolute value of x less than equals to a, then this is equivalent to, you write down whatever you have inside the absolute value, we have x. Okay, you're going to use the same inequality. Okay, with equals to, so you're going to have greater than on the left side, greater than equal to on the left side, and less than equal to on the right side. Okay, on the left side you're going to have a negative of right side, which is negative a, and positive of right side, which is a. Okay, so these two are equivalent. Okay, so these two are equivalent, they are same inequality, nothing is different. Okay, in the first inequality we have the absolute value, in the second inequality we don't have the absolute value, but both of these inequality are same, they both have a same set of solution. Okay, and the next condition we had, if we have absolute value of x greater than or equals to a, okay, then this is equivalent to x is less than equals to negative of a, or x is greater than or equals to positive a. So if we have greater, then you're going to use this definition, x less than or equals to negative a, or x greater than equals to positive a. That's what we have. Okay, if we go back here, so we have the definition here. Okay, so this is what we have. If you don't have equal to, then you are not writing equal to. Okay, now let's use this definition to solve one more inequality. So we are at number D, so let me get rid of this thing here. So we have negative 4 plus absolute value of 3 minus x greater than 5. We need to find the solution set for this inequality. Now here we have to just have absolute value by itself in one side. Okay, we have negative 4 here, so let's get rid of negative 4 from left side, and for that we add 4 on both side. So after that we have absolute value of 3 minus x is greater than 5 plus 4, 9. Okay, now for the inequality we have the two definition. Okay, we have the two definition. So here are the two definition. Okay, so which definition do we use, first or second? So we have the greater than, right? So we have the greater than, so we're going to use second definition. And according to second definition, you write down whatever you have inside the absolute value less than negative of right side, or you write down whatever you have inside the absolute value greater than whatever you have on the right side, positive. Okay, so according to this rule 2, so we're gonna have, you write down whatever you have inside absolute value, 3 minus x less than, we don't have equal to here. Okay, now negative of 9, which is negative 9, or we're gonna have 3 minus x greater than positive of right side, which is positive 9. So from one absolute value inequality we have two different inequality. Now we solve each of these inequality. So in order to solve first inequality, we subtract 3 on both sides. For the second inequality, we do the same thing, subtract 3 on both sides. Positive 3, negative 3 cancel. So we have negative x less than negative 9, negative 3, that's negative 12, right? Or positive 3, negative 3 cancel, and we have negative x greater than 9 minus 3, that is 6. We still have negative in front of x. We need to get rid of negative x. So negative. Now how do we get rid of negative? Okay, so you can divide both sides by negative 1, or you can multiply both sides by negative 1. Okay, still same thing. So if you divide both sides by negative 1, and what happens to the inequality? Does it remain same?
It flips.
Right, so it flips. Okay, so let me, okay, so I'm gonna cross out this one here for a while. Not okay. So we have from here, so we have negative x divided by negative 1, that is positive x. Now the strictly less than is, it flips, and we can have greater than positive 12, or so negative x divided by negative 1, that is positive x. We have greater than, it changed to less than negative 6. Now we draw a number line. Okay, we have negative infinity, we have positive infinity, we have negative 6, we have 12. Now at negative 6, do we have an open circle or a closed circle? Open, because we have strictly less than, there is no equal to sign, so we're going to have an open circle at 6, sorry, negative 6. What about positive 12? Closed circle or open circle? Open, right? There is no equal to here, so we can have open. Okay, so we have now, so this is our part 1, so part 2, part 3. So where do we find a number x which is greater than 12? In which part of a number line do we find a number greater than 12? On the part 3, right? So let's say this part. So this is the one, and we have number less than negative 6, so it's on the left of negative 6. So these two parts of a number line are the solution for this inequality. Let's write down the interval. So for the first interval, we have from negative infinity to negative 6, we have open circle, so we can have parentheses. For the next third part, it's starting from 12 all the way to the positive infinity, we have open circle, so parentheses. With infinity, it's always parentheses. Okay, now here we have a or. Okay, and we replace this or by union, and this is our final answer. So negative infinity to negative 6, or 12 to 8. So this is our final answer. Okay, so I need to erase this here for number, for other column. Okay, can I erase this now? Okay, so the next example here we have, so let me erase this. Graph on a number line and write each using an absolute value inequality. Okay, so we have the set of x whose distance from 4 is less than 5. So how do we write this using the absolute value inequality? So we have a set of all x. Okay, we need to write down the set of all x whose distance from 4 is less than 5. So how do we write the how do we find the distance of x from 4? How do we find the distance of x from 4? Okay, like for x, let me take 10. Okay, x can be any number. So for right now, let's take 10. So what is the distance of 10 from 4? Do you all agree? It's 6. Okay, so if it's negative 2, what will be the distance of negative 2 from 4? It's 6, right? So how did you find that? It's subtract, right? That's what we're going to do. So our number is x here in general. So we have the distance is x minus 4, and the distance has to be always positive, right? And how do we write that positive here? We use the absolute value. So we have absolute value of x minus 4, and the distance is always less than 5. So we have less than 5. So this is for A. Okay, so the set of all x whose distance from 4 is less than 5 is same as absolute value of x minus 4 is less than 5. Okay, for number B, so we have the set of x whose distance from 4 is greater than 5. So we have absolute value of x minus 4. This is the distance of x from 4 greater. So this is absolute value, not the parenthesis. So you're going to have absolute value and greater than 5. This is for the number B. So the distance of x from 4 is greater than 5. Okay, this is all for example 2. Get with this one. Okay, let's go to the next one. So here, so we have a thermometer measure temperature with an uncertainty of 0.25 degree Fahrenheit. Okay, so this is the uncertainty. If a person's body temperature is measured at 98.3 degree Fahrenheit, use absolute value notation to write an inequality for the range of possible body temperature. Okay. Now, so the thermometer, its uncertainty is 0.25 degree Fahrenheit, and your body temperature is 98.3 degree Fahrenheit. So, what are the chances? Like, what is the range of body temperature that is given by this thermometer?
Plus or minus 0.
Yes. So it means uncertain means you can have your body temperature plus 98.3 degree plus 0.25 or 98.3 minus 0.25, right? Because 0.25 is the uncertainty. It can be a plus 0.25 or minus 0.25. Okay, now we will be writing that. So here, so let's call our body temperature as x. Okay, so in general, okay, so in general, let's call our x that represents our body temperature. Okay, now x can be, okay, less than or equals to our 98.3 degree plus 0.25. Okay, well, it's not necessary to write down degree here. Okay, 0.25, or it can be greater than or equals to 98.3 minus 0.25. Okay, so our x, our temperature, okay, we use x to represent that temperature. Okay, and that temperature can be greater than equals to 98.0.25 or less than equals to 98.3 plus 0.25. Okay, now here, how can we rewrite this one? Okay, now, so we have 0.25, 98.3. Okay, but we need to write using absolute value notation. But we don't have absolute value notation here. How can we use absolute value notation here? This is what we know. This is the range of the temperature that we're gonna have. Okay, let's call the temperature x. Okay, so here our temperature is x. Okay, then our the person's temperature is 98.3. The difference of these two, okay, the difference of these two is has to be always, what should be the difference here? So we have x, it can be any temperature. Okay, that's the x is our accurate body temperature. Okay, so x minus 98.3, the difference has to be the uncertainty, which is 0.25. Okay, it can be equals to 0.25 or it can be less than 0.25. So this is the expression, absolute value inequality for this case here. And we can rewrite. Okay, so once you have this, you can just rewrite using our definition. Okay, now, okay, so here let me use this one. We can use this expression. These two are equivalent. Okay, so here, so let me take this one more time. So we have 98.3 minus 0.25 less than equals to x less than equals to 98.3 plus 0.25. So let's subtract 98.3 here. So let's subtract 98.3. So make sure you are subtracting everywhere. 98.3 subtracting 98.3. So this cancel. So this cancel. This cancel. Okay, and we have negative 0.25 less than equals to x minus 98.3 less than equals 0.25. Now using our very first definition, okay, now if we go back to our definition, just let me take back to definition here. So this is the definition. So here, so if we have anything like this, if our x is greater than negative a and less than a, this is equivalent to absolute value of x is less than a, and we use this concept here for our final answer. So see, so this is our x, okay, this is our x, this is our a, and this is our a. So we have x greater than equals to negative a, right? We have negative a less than equals to a, and this is absolute value of x, which is x minus 98.3. We're gonna use the same inequality, less than equals to 0a, which is 0.25. Okay, we use our definition here. So this is the expression, this is the inequality expression for a given situation. Okay, this is all for section 1.6. okay.